idea is before you evaluate the variables, you may need to increase by 1 or decrease by 1 so that you can add certain values before you evaluate your variables, or decrease by 1 before you evaluate the variables. So first one, increment operators. There are two of them, preincrements and then postincrements. It is pretty same as a prepaid phone or a postpaid phones. Okay, so you may credit certain amounts before you use your phone credit, or you can use your phone, then you can pay your phone usage later on. That's postincrements. Here's the example for preincrement operator. It looks like a plus I. Okay, plus is operator, or we call it a preincrement operator. So before we use preincrement operator, we declare I equal to 1. Then declare J depends on plus I. That's how we read it. So here plus I means increase I by 1, integer value 1, and then use the new I value in the statement. So I, in this case, I become 2 because it's 1 plus 1. Then assign to J, so J become number 2. Then we end the statement with the semicolon. Let me draw the block that represent a variable in memory. So we have one small memory block, declares I, assign integer value number 1. Let me repeat the same thing. We still have a variable I when you go to second statement with the value number 1. Then we declare a second variable J. The value depends on plus I. So as it is, increase by 1 plus 1. So 1 plus 1 equal to 2. That's the value J. Postincrement operator. Pretty much same example. Int I equal to 1. Int J equal to I plus plus. So I plus plus means increase I by 1, but use the original I value in the statements. So in this case, I equal to 1. We assign number 1 to J, so J become number 1. So there will be no changes to I. After we finish the statement, I become number 2. Again, let me use a block diagram. Okay, increase by 1. Still use the original I value. So memory location, we have a variable I with the integer value 1. Then next statement, we still have a variable I with the value 1. Declare J on the block for J. J depends on I++. So I is holding number 1. We are not going to increase until we finish this statement. So we use the original value 1. Okay, so we assume that there is another statement. If we try to print I, is the number 1? No, it becomes number 2 because we increase by 1 after that statement. So I become number 2, J is still number 1. We assume that there are additional statements, okay? Like a system out, print ln, print I and J. Decrement operators are exactly the same, and increase, instead of increase by 1, we decrease by 1. Either before and after statement. Okay, let's create a new Java project with the default main class. Let me add the title. Increment and decrement operators. So let me declare I equal to 1 and J depends on plus I. Let me evaluate output J. You may like to double check I here. So I is, if we print I is number 1, J is become 2 because it's a pre-increment. Before you evaluate I, we increase by 1. So clean and build and let's check. 1 and 2, correct. What if we change the post increment? I is still 1. Because of that, J is still number 1. But if we print next line, line number 22, J is still 1, but now I is 2, or become 2. Because we increase by 1 after statement number, line number 21. Okay, I is 1, J is 1, correct. Okay, let's print one more time for I. so that whether I is still number 2 or not. No, I mean I is become 2. So 1, 1, 2. So we move to predecrement, means minus minus I. So if we look at line number 19, I is number 1. J is depends on minus minus I. So decrease I by 1. Then assign that value to J. So J is 0 now. I is 0. So next statement, J is obviously 0. And then I is 0. Clean and build and learn it. Okay, 1, 0, 0. Correct. Let's move to post-decrement. I minus minus. Okay, J is depends on I. Because I is still integer value 1. After statement on line number 21, I become 0. But in this line 21, J is still, J is 0. I is still 1. So J is 0, correct? On line number 22. On line number 23, I become 0. Okay, let me write it down explanations, then I will end this tutorial. Okay, thank you.